Alright, I'm back to working with the exciters. This happens to be the Slayer exciter, and I'm working with in conjunction with a pulse motor and the exciter. And what I'm studying now is capacitance and an earth ground in conjunction with the exciter circuits and how it interplays with a load. And this happens to be a little 1.5 volt pulse motor that I built, and there's Maggie in the background there picking up the energy off the pulse motor. It's just a bifilar simple pulse motor, my light multiplier basically. That's the little circuit for it right there. This side is the Slayer exciter, and it is not on, you notice. And I'm running the Slayer exciter tonight on a 6 volt battery. And this is the amp draw on the pulse motor. It's about 2.5 milliamps. This is on a milliamp scale. And I'm running it off a 1.5 volt or 1.34 volt rechargeable battery. Notice the 6 volt battery is not connected. These are independent circuits. These are not connected like my Giulini exciter. These are independent now. But what I'm going to show is the energy I can pick up off of a piece of aluminum underneath this plastic cutting board using an AV plug, Alvin Minkle plug, and a capacitor, and then feeding the energy back toward that battery using the exciter. And what I want to show is this amp draw and how that amp draw goes down with the exciter adding into it. Okay, let me hook up the exciter now. Watch the bulb here. Okay, there goes the exciter. The exciter is on now. And right away you notice there went some amp draw. The amp draw went down on the pulse motor. All I did was turn the exciter on, the battery's sitting right there, and the amp draw went down. Now what I want to show here is I'm going to lay this battery down flat on that board. Now remember, this is a plastic cutting board on top of a piece of aluminum, and I'm going to pick up energy through a capacitive link from that battery into that capacitor and reduce my amp draw. Here we go. Look at that. You notice that has a minus sign on it now. The energy now is not coming out of that battery. The energy is coming out of that battery through a capacitive link using this exciter circuit back into the capacitor, back feeding the system, and the pulse motor is still going. Now, people are going to go, well, it's just your meter's acting funny. And that's how these digital meters go, and you're just seeing a phony reading. And I have to agree, they do lie to you, so you have to be very, very careful with these, that you double check. And what I'm going to do here is take the battery out, and you'll notice the motor just keeps right on going. You won't see an amp draw then because the battery's disconnected, but I'll show you the motor still going here. Okay, there's the battery disconnected. There's the motor still running. That could actually speeds up when I do that. Now the other thing I wanted to show is I want to show what happens when you hook up an earth ground into this system. So let me plug this battery back in. There goes the energy going back into the battery. Now I'm going to connect this earth ground up and watch what happens here. See the bump? And that's where this earth ground helps you. And I'm not exactly sure how and why that's working. My experiments with these before is this does not increase the load on that battery. The exciter part of this runs merely along with whatever you're doing, independent of what you do on the external part of this. You will dim down the lights if there's more lights involved, but you won't increase the amp draw. And these lights, if you load the environment around this thing, your lights dim down, but it does not draw more power from that battery. So anyway, what I've got here now is I've got 4 milliamps going back into that battery. I'm charging that battery through that capacitive link right there through an AV plug, and I'm still running the motor merrily along, and I'm still making Maggie do her thing. So this is quite interesting study that I'm doing right now with this capacitive link and earth ground with the exciter circuits. Dr. Stifler is doing a whole chain of videos using his circuit, and does not want us to try to replicate it until he is finished showing us how to do what we're doing. But anyway, I thought I would just fiddle around with what I know and see what would happen with these capacitive links and the earth ground. There's no freebie here in my setup at all. I'm pulling energy out of that battery. That's no mystery. It's just how I'm manipulating it around here. I find it rather interesting. And it's all about me. It's all about making light for the least amount of power I can. And when I make light, what I'm going after is the bang for the buck. How much energy is it going to take to make how much light? And how much light can I pull off of things based on the amount of wattage. So that's what I'm interested in. Anyway, that's the little demonstration for today. That's my little project I've been working on, and I'm watching Dr. Stifler's videos intently. Thanks for watching. Bye-bye.